Okay, so let's take a look at Lab 3, Introduction to Measurement. I'm just going to highlight a couple of the things that may not be completely intuitive or maybe a little bit in hiding. So first and foremost, one of your classmates mentioned that it's possible to do something called a split question view, which makes it possible in some labs to not have to scroll down and then back up all the time. It apparently doesn't work very well for this lab, but I'm still going to use it. So I'm going to click on Show Split Question View. And here we are on part 1, Introduction to Measurements, with the very first question. Now, in this question is just an image of what a video is going to play later. In every exercise, you should always read carefully all the instructions. So it's super important that you do that. And for instance, in this question, you are told that a graduated cylinder is an instrument used to measure the volume of a fluid or of a liquid, that there's something called a meniscus, and that you're supposed to read the volume and take a best guess as to what that volume may be. You may be able to pinch into some of these images, depending on the browser that you're using, to take a look, take a closer look at the image. In this particular exercise, two things to notice. This cylinder measures in milliliters, and the volume displayed by this fluid is about 80 milliliters. Remember that you always take a guess as to the last digit of the number. So I'm going to look at the answers, see that some of them have units of liters, so those two are out, the top and the third one. The other two have slightly different numbers, 81.0 milliliters or 80.0 milliliters. In my view, the cylinder has a volume closer to 80 than to 81. That's what I'm going to be choosing. Now there's a second question in which you're supposed to read the scales output, which if you zoom into it, you can see that is 166.6. The units are not visible. They're going to be always grams, and you make your choices from here. Now, one thing that is interesting about this question is that whatever you read on the screen is not necessarily the weight that they're asking you to measure. They want you to measure the weight of the liquid, not the weight of the liquid plus the cylinder. So you need to do some subtraction. You need to take a look at the image, realize that it is in fact 166.6, but in the explanation they tell you that the scale was not reset to 0, something called the tear of the scale. So the mass that you see there, 166.6, includes the weight of the cylinder. And they tell you here that weight, that mass of the cylinder was 42 grams. So the 166 grams minus the 42 grams will give you the volume of the liquid alone. Now, in order to proceed to the next section, in my case, I need to log the answers so that I can open the next section. Of course, you're given a warning. Always read pop-ups, always read instructions carefully. So now I am here on part 2, graphing and unit conversions. You have a video that you can play. You go ahead and play that video and make recordings. So for instance, in this particular video, what you're doing is you're adding a certain amount of liquid into this graduated cylinder. You're going to be pausing this video to take a note of the measurements. I can see here that the liquid has a volume of approximately 22 milliliters. There is a table here that I can populate with that. That volume is going to be this last column. So I'm going to simply put 22 milliliters. I'm going to add one guess digit, which is going to be a 0.0. The units are given here on this column by milliliters, and that's the entry. Now, please notice that I actually went ahead and skipped the very first reading, which actually, if I go back, I'm going to see that at the beginning of the experiment, there is absolutely nothing on the cylinder. It's an empty cylinder. But there is a mass that the cylinder weighs. Let's go back a little bit. 0 grams. So this scale is 0 or is at 0. But once we place the cylinder on it, it has a readout, 96.4. So keep in mind that mass. Now the cylinder is empty. So look what I'm going to do with this table. I'm going to move this 22 to the second measurement. And I'm going to erase the 22.0 and simply make it a 0 because there's nothing there. However, that mass can be either the mass of the liquid itself or the mass of the liquid plus the cylinder. Now, because there's no liquid in the graduated cylinder at this moment, I know that the 96.4 grams is the mass of the cylinder by itself. So I'm going to put it right here, 96.4. On the liquid mass, I know there's nothing yet, so I'm going to write 0. Now, we're going to play the video and go to when we added the 22 milliliters of liquid, and then I'm going to pause it. So if I pause the video right here, I can see again that there are 22 milliliters of this liquid in here, which is a number that I have already over here. But the mass now is 124.2. Now that mass is of the cylinder plus the liquid. So I'm going to put it under the column named measure mass, 124.2. Now what goes here? Well, you can calculate the mass of the liquid by itself by subtracting 96.4 from 124.2 and then putting that number here. Or better yet, you can go to this column, click on the 3 dots, the ellipses, and check this out. You can change the column formula by clicking on that label. This brings up this particular calculator looking thing. If I click on measure mass, the measure mass is going to be put up here on under the formula that I want to enter. And then I'm just simply going to hit the negative sign, the minus sign, and then the 96.4 grams of the graduated cylinder. Oops, I need to put a period. 96.4. And I'm going to submit that. So when I do that, I get a warning, read what the warning says, and just go ahead and accept it. But check this out. The mass of the liquid itself is now calculated automatically by the formula by subtracting 96.4 from 124.2. If you do the same for the next reading, you're going to see that that happens again. And then if we scroll down over here, we can see that there's a graph being built for us. That graph can provide some important information. So let's enter one more data point, data pair. I'm going to move the video to the next measurement of volume. I'm going to record this volume as 36. That's what I read. And then I'm going to enter the mass on the scale as 141.3. The mass of the liquid is automatically calculated, and that mass of the liquid is what is being plotted over here under measure mass. Actually, now that I notice, this is actually measure mass, and I just want the liquid. So I'm going to change that by clicking on the label and changing this to liquid mass. And now I'm going to say, okay. And what I am plotting now is simply the mass of the liquid versus the volume of the liquid. One last thing that I want to show you. If you click on this gear, you get this menu where you can actually select something called curve fit or curve fits. If you click on that, you're given the choice to create a formula that applies to that graph. And we're going to choose the linear formula. This is the equation of a straight line. Y equals mx plus b. In this case, the m, which I refer to as the slope, is actually labeled a. So a is the slope, m is the slope in the way I learned this equation a long time ago. Same thing. So I'm going to select that, apply it, and now I see that there's a straight line being painted or graphed. And more importantly, I have some important information here to look at. I'm going to let you explore that, but I want you to pay special attention to this A, the slope, because the units are grams per milliliter, and that should tell you something. Okay, I hope this introduction to lab number 3 is of help to you. Thank you.